So let's get a sneak peek of functions of two variables before they're used more extensively in Calculus 3. So a typical function has one input, a function of one variable has one input and the output, one output. Functions of two variable, you give two independent inputs, right? So the independent variables are two and you return one output, okay? So you'll have two independent variables and one dependent variable on those two independent variables. Okay? Many things in the world are actually functions of not just two variables, but more than one variable. For example, the body mass index takes height and weight. So we could represent functions of two variables, say, with a table. Take a look at the BMI, for example. It's a function. The two independent variables are height and weight. Those are the inputs. And the output is the BMI. And so, for example, if the weight is 160 and the height is 69, you look at where these two will intersect, 24, and you'll get BMI. For example, here, if we're going to fill in this example, we'll have F60 and weight 200, and so that's going to be 39, okay? And we could see that F increases with weight, okay, and it decreases with height, okay? We could also represent functions of two variables algebraically. And what we mean by algebraically here is that we would actually, just like we have function of one variable, we'll write the x. Well, we could write out an xy or a dm. For example, in this case here, we have a car rental company charges $40 a day and 15 cents a mile to rent its car. We want to write the formula for the cost of renting this car as a function of the number of days d and the number of miles. Okay, to do that, well, it's 40 per day, and so it's 40 times the number of days, and 15 cents a mile, and so 0.15 times m. This here is a function of two variables, the days and the miles that you drive this car. If c is equal to fdm, find f for 5 days and 300 miles. So we'll just plug those values in and we get 245, again using the algebraic representation. And so we'll have the cost of renting a car for 5 days and driving it 300 miles is $245. Finally, we could represent functions of two variables graphically, right? For functions of one variable, we just had a simple curve, the curve xf of x, okay? That was called the graph of the function of one variable. What about two variables? Here, the graph, you need a third axis. You need the z-axis, okay, to represent the graph of a function of two variables. So if your two independent variables are x and y, then z is the output. Z is the dependent variable. And here you could see a sketch of the function x squared plus y squared. And here, again, say we want to know what the value of f is at y at this point here, 1, 1 on the xy. Well, that's going to map up to, it's going to be f of 1, 1 is equal to 1 squared plus 1 squared, or 2. And so this is going to map up to 2. Okay, and you can see here that that's going to be level with the 2 on the z-axis. And so that's how we could represent the functions of two variables graphically.